it is time to learn all about Archimedes.
Ready for a deep dive into the mind of Archimedes
Okay.
to uncover the brilliance of this ancient genius,
Yeah.
a figure who still resonates
Uh-huh.
with mathematicians and scientists today.
What's fascinating is how much of his work
Yeah.
was driven by the practical needs of his time.
That's true.
Yet he was able to extract universal principles that have endured for centuries.
We all know the Eureka story,
Right.
but few realize Archimedes may be a key reason why we believe the Earth is round, or that he foreshadowed modern calculus.
Let's start with what we know about the man himself.
Okay.
The details of his life are surprisingly scarce.
Really?
Born in Syracuse, Sicily,
Right.
around 287 BC.
Uh-huh.
A possible relation to King Hiero II is debated. Much of what we know comes from later historians
I see.
who focused on his inventions
Okay.
rather than his personal life.
It's as though his work overshadowed the man himself.
Yeah.
Even his tomb, marked by a sphere and cylinder,
Right.
representing his favorite proof,
Yes.
was neglected until Cicero rediscovered it.
Wow.
It makes you wonder,
Yeah.
what was so groundbreaking about that proof?
That sphere and cylinder represent Archimedes' work
Oh, yeah.
on the volume of a sphere.
Right.
A problem that had stumped mathematicians for ages.
Wow.
He proved that the volume of a sphere is 2/3 the volume of the cylinder. It fits perfectly inside.
It's hard to imagine
Yeah.
how challenging that would have been
I know.
with the mathematical tools of the time.
Right.
And yet, he was solving problems that continue to form the basis of geometry today,
Exactly.
and that problem-solving genius
Yes.
extended to his inventions as well.
Uh-huh.
Take the famous Eureka moment
Right.
with the golden crown.
The classic story.
The king suspects a goldsmith
Okay.
of mixing silver into his crown,
Yeah,
and Archimedes has to find out without destroying it.
he does.
Enter the bathtub.
Right.
While the bath story's accuracy is debated,
Okay.
the principle behind it,
Yeah.
Archimedes' principle,
Yes.
is undeniably important.
It states that a body immersed in fluid
Uh-huh.
experiences an upward force
Okay.
equal to the weight of the fluid it displaces.
So he could compare the crown's displacement to
Right.
that of pure gold,
Exactly.
revealing the fraud.
Uh-huh.
It's incredible how that principle is fundamental to everything from shipbuilding
Right.
to understanding why things float.
And his ingenuity
Yeah.
extended beyond the theoretical.
Give me an example.
Think of the Archimedes screw.
Okay.
A simple yet effective device
Uh-huh.
for pumping liquids and solids.
Wow.
Still used today.
I've seen them used for irrigation.
Yes.
Even for moving grain.
It's true.
Such a practical solution.
Yeah.
Inspired by ancient screw pumps.
Right.
Possibly those used in the Hanging Gardens of Babylon.
It's remarkable how he drew inspiration from the world around him
I agree.
and turned it into practical solutions.
And then there's the Syracusia,
Oh, yes.
the massive ship.
The largest of its time,
Wow.
decked out with gardens,
Really?
a gymnasium, even a temple.
Amazing.
Launching such a behemoth
Yeah.
required a deep understanding of buoyancy and weight distribution.
Talk about an ancient engineering marvel.
For sure.
And speaking of engineering, we can't forget the Archimedes claw,
Right.
that legendary weapon
Yes.
designed to defend Syracuse.
Imagine a crane-like arm with a grappling hook.
Okay.
It would lift enemy ships out of the water,
Wow.
potentially capsizing them.
Really?
Modern experiments have even confirmed its feasibility.
It's almost like something out of a science fiction movie.
Yeah.
But this wasn't just brute force.
It wasn't.
Archimedes was famous for saying,
Mm.
give me a place to stand and I will move the earth.
A bold claim,
It is.
but grounded in his rigorous understanding of leverage. He proved the law of the lever,
Okay.
explaining the relationship between force, load, and distance, a concept we use daily without even realizing it.
From simple tools to massive ships,
Right?
he seemed to grasp the fundamental principles governing the physical world.
Exactly.
But his real genius lay in mathematics.
Oh, yes.
He was a pioneer,
He was.
anticipating concepts like calculus centuries before they were formally developed.
Really?
How so?
He used a method called exhaustion
Okay.
to approximate values like pi and the area of a circle.
with incredible accuracy.
So he was basically calculating pi without modern tools.
Precisely.
Wow.
Imagine inscribing and circumscribing polygons around a circle,
Okay.
constantly increasing the number of sides.
Okay.
You're essentially exhausting the space between the polygon and the actual shape.
Right.
Exactly.
And this led him to a surprisingly precise calculation of pi.
Yes.
Using polygons with 96 sides.
96 sides.
I'm getting a headache just picturing that.
But that's the brilliance of Archimedes.
Yeah.
He found ways to tackle problems that seemed impossible at the time.
It's mind-boggling.
It is.
And this method of exhaustion
Yeah.
was essentially a precursor to modern calculus.
In a way, yes. It laid the groundwork for understanding limits and infinite series.
Okay.
And it's just one example of how Archimedes was pushing the boundaries of mathematical thought centuries before his time.
So we have the inventor,
Yes.
the engineer, and
Yeah.
now the mathematician.
Right.
Was there anything this man couldn't do?
Actually, his curiosity extended beyond the Earth.
Really?
He also made significant contributions to astronomy.
Astronomy.
Like what?
Yeah, like what?
He made accurate measurements of the sun's diameter and observed solstices. He even designed complex planetariums, those intricate models of celestial motion.
Imagine the precision and ingenuity required to build a working planetarium in those days.
It speaks volumes about his understanding of celestial mechanics.
Yeah.
But perhaps the most remarkable example of his ambition is his work, The Sand Reckoner.
What's so special about counting sand?
In this work, Archimedes attempts to calculate the number of grains of sand it would take to fill the entire universe.
The entire universe?
Yes.
Wow.
He even had to develop a new system of counting to handle such massive numbers.
It's like his mind was constantly searching for the biggest, most challenging problems to solve.
Right.
It makes our modern-day problems seem almost trivial in comparison.
And that's what's so captivating about Archimedes.
Yeah.
He was a true pioneer. A testament to the boundless possibilities of human intellect.
Well, after exploring just a fraction of his accomplishments, I'm already feeling inspired.
And his work continues to inspire us today. Think about it. From the practical applications of his inventions to the foundational principles of math and physics.
Right.
His legacy is woven into the fabric of our modern world.
It's incredible to think that principles discovered so long ago are still so relevant today.
I know.
Let's delve a bit deeper into some of those mathematical concepts.
Okay.
The Archimedean property.
Yes.
Can you explain what that is?
It's a fundamental concept in mathematics, particularly in dealing with real numbers.
Okay.
In simple terms.
Yeah.
It states that no matter how small a number is, you can always add it to itself enough times to exceed any other given number.
So even if we take a tiny fraction,
Right.
like 0.00001, and keep adding it to itself, we'll eventually reach a number larger than, say, 1,000,000.
Exactly.
Wow.
It might seem obvious now,
Okay.
but this property is crucial
Yeah.
for defining the concept of infinity and understanding the continuum of real numbers.
Okay.
It's a building block for many areas of mathematics.
It's amazing how such a seemingly simple idea can have such profound implications.
It is.
The article also mentions his work with infinite series.
Right.
Wasn't that a concept explored much later in history?
Yes, Archimedes was centuries ahead of his time in this regard.
Really? He used infinite series to solve geometric problems,
Right.
like finding the area enclosed by a parabola in a straight line.
How did he even approach that without the tools of modern calculus?
He cleverly expressed the solution as an infinite geometric series. Imagine a triangle inscribed within a parabola.
Okay.
Archimedes showed that the area between the parabola and the line could be calculated by adding the area of that triangle,
Right.
plus 2 smaller triangles within the remaining space, then 4 even smaller ones, and so on indefinitely.
So he was essentially adding up an infinite number of progressively smaller triangles.
Precisely.
Ah.
And he proved that this specific series,
Yeah.
where each term is 1/4 of the previous term,
Okay.
converges to a finite value, giving you the area of the parabolic segment.
He was practically doing calculus without even realizing it.
I know.
It's mind-blowing how he intuited concepts that wouldn't be formalized for centuries.
His intuition was remarkable. And it wasn't limited to pure mathematics.
No, it wasn't.
His treatise on floating bodies
Yes.
explores the principle of buoyancy, which is fundamental to physics.
Wait, the principle behind why things float or sink.
Can you elaborate on that a bit more?
Archimedes' principle states that any object fully or partially submerged in a fluid, experiences an upward force equal to the weight of the fluid displaced by that object.
So if an object displaces a certain amount of water,
Yes.
it experiences an upward force equal to the weight of that water.
Exactly.
And this principle explains why ships, despite their massive weight,
Right.
can float.
If the upward buoyant force is greater than the object's weight, it floats.
Okay.
If the object's weight is greater, it sinks.
It's the foundation of shipbuilding
Yes,
and explains how submarines work.
it does.
His work on floating bodies doesn't stop there, does it?
You're right.
Okay.
He also delves into the concept of equilibrium in fluids, demonstrating that water at rest takes a spherical shape around its center of gravity.
Okay.
This was one of the earliest scientific arguments supporting the idea of a spherical Earth.
So even back then, there were ideas about the Earth being round.
Yes, and Archimedes' work provided further evidence to support those ideas.
His influence on scientific thought is undeniable.
It is.
It's fascinating how scientific knowledge builds upon the discoveries of those who came before.
It is. Okay.
Called ostimation.
Right.
What exactly is that?
The ostimation
Yeah.
is a dissection puzzle,
Okay.
similar to a tangram.
Uh-huh.
It consists of 14 pieces that can be arranged to form a square.
So it's kind of like a geometric jigsaw puzzle.
Yes, but with a mathematical twist.
Mm.
Archimedes was interested in the number of different ways.
Okay.
These 14 pieces could be combined to form a square.
It sounds like a deceptively simple puzzle that could lead to some complex mathematical explorations.
Absolutely. It's considered an early example of combinatorics,
Oh.
a branch of mathematics dealing with counting and arranging objects.
So Archimedes was exploring concepts in combinatoric centuries before the field was formally established.
It appears so.
Wow.
His curiosity truly knew no bounds.
And speaking of boundless curiosity, we can't forget the cattle problem.
The cattle problem.
What is that?
It's a mathematical problem presented in the form of a poem, challenging mathematicians to calculate the number of cattle in the herd of the sun.
Okay.
This seemingly simple setup involves solving a complex system of simultaneous Diophantine equations.
Diophantine equations.
What are those?
Yeah, what are those?
They're equations where we're looking for integer solutions,
Okay.
which can be quite challenging to find. In the case of the cattle problem, the solution is an incredibly large number.
Really?
It wasn't fully solved until the late 19th century using advanced mathematical techniques.
So Archimedes was posing math problems that took centuries to solve. He was truly setting the stage for generations of mathematicians to come.
Yes, he was.
But there's one more thing I want to talk about.
Okay.
The Archimedes palimpsest.
Oh, yes.
What can you tell us about that?
The Archimedes palimpsest is one of the most exciting discoveries in the history of science.
Wow.
It's a 10th century manuscript
Okay.
containing previously unknown works by Archimedes that were thought to be lost forever.
Wait, so these are writings of Archimedes hidden for centuries?
Essentially, yes.
Wow.
The palimpsest was originally a book of prayers,
Okay.
but the text was scraped off and reused to create the prayer book.
I see.
Fortunately, the original text wasn't entirely erased.
Okay.
With modern imaging techniques,
Uh-huh.
we've been able to recover some of Archimedes' lost writings.
It's like finding a hidden treasure trove of ancient knowledge.
It is.
What kind of insights did these lost writings provide?
The palimpsest contains several treatises,
Okay.
including the only surviving copy of On Floating Bodies
Right.
in the original Eureka. It also included the method of mechanical theorems, where Archimedes describes a method for discovering mathematical theorems using mechanical principles. This was a groundbreaking approach, linking geometry and mechanics in a way that hadn't been seen before.
So he was constantly finding new ways to approach and solve problems.
He was.
It's remarkable.
It is.
What happened to the palimpsest after it was rediscovered?
It was purchased by an anonymous buyer at an auction in 1998.
Wow.
For $2.2 million.
Really?
It's been extensively studied by scholars, providing invaluable insights into Archimedes' thinking and mathematical methods.
It's incredible to think that centuries after his death, Archimedes is still capable of surprising us.
He is.
Well, I think we've thoroughly explored the life and work of Archimedes.
I think we have.
This has been a fascinating journey
It has.
through the mind of a true genius.
It has been a journey that everyone can take.
It has.
Archimedes' work continues to inspire and challenge us to think differently, to question our assumptions, and to never stop exploring the unknown.
Well said.
Thank you.